Looks like we've got a cold one, Julius. It's a shame. It was so young. Everyone's got an enemy, and this kid's enemy got him killed. I talked to his parents. They said Rob here was a gangster. He had a lot of them enemies. You don't say, Doc. I heard a lot of these gangsters have been taken out around town. Must be a powerful force doing it. Yeah, but I don't understand how they're killing these youngins without leaving any blood on the ground. It makes for a clean getaway. Well, it must have come from within the room, judging from the walls that there's no gunshots. Maybe a poisonous gas or substance killed him, stopped his heart. You're exactly right, Julius. The heart must have stopped between 7:29 p.m. and 8:09 p.m., judging from how cold the body is and the time the report of his death came in. I was thinking the same thing, Doc. But let me ask you something. How could someone stop this kid's heart with a liquid or gas substance? I mean, the kid was clearly in great shape. How is it possible that he didn't survive? Well, the heart is a delicate thing, Julius. The heart is made up of 4 chambers, the left and right atriums and the left and right ventricles. These left and right sides are separated by the septum. The septum keeps blood from these 2 sides from leaking over to the other. The atria and ventricles are separated by valves that open and shut so as to prevent backflow of blood from the ventricle back into the atrium. On the left side is the mitral valve, and on the right side is the tricuspid valve. All of these valves and chambers work in unison by relaxing and contracting to move blood out of the heart. The blood in the heart is moved out through electrical impulses that start at the sinoatrial node and passes through the atrial syncytium. With this, atria begin to contract. The impulse is then passed to the atrioventricular node inside the septum between the 2 atria. The atria are fully contracted and empty out of all of this blood. After the atrioventricular node, the impulse is moved to the atrioventricular bundle and branches into the ventricles beneath the endocardium. Midway down the septum, these turn into Purkinje fibers, which conduct the impulse back up through the left and right ventricles. Once these impulses stop, the blood can no longer be pumped out of the heart, which is why Rob here ended up dead cold on the ground, even at his young age. That's a lot of complications, Doc, but I have to wonder what the structures of the heart look like, and how their structures add to the efficiency of their function. Great question, Julius. The atria are smaller than the ventricles, and their walls are weaker. This is because the atria do not need to hold as much blood as the ventricles, and they do not need to use as great a force as the ventricles to pump blood out of the heart. The ventricles are larger and have thick walls because they require more force in pumping blood out of the heart into the arteries, veins, and capillaries. So what exactly are the structures and functions of the veins, capillaries, and arteries? Well, the arteries have thick walls that are able to support the high pressures of blood that travel through them. The arteries have 3 layers: the tunica intima, tunica media, and tunica adventitia. A 3rd layer of tunica media consists of elastic fibers that allow the arteries to expand way more than the capillaries and veins. The capillaries receive oxygenated blood from the arteries. The structure of the capillaries consists of a single layer of endothelial cells. The capillaries do not have to withstand high pressures of blood, so they do not require as thick of a wall as the arteries. The capillaries deliver to blood from the arteries to the blood's tissues and collect carbon dioxide waste materials and fluids for return to the veins. The vein structure is more like the arteries rather than the capillary. The veins do not have a thick tunica media and therefore cannot expand as much as the arteries, but the veins do not need to expand as much as the arteries because they do not encounter high pressures of blood, but rather return the deoxygenated blood back to the heart. Seems like you really know your stuff, Doc. Tell me this. What function does the circulation of blood play in keeping good old Rob here alive? Well, Julius, it's funny you should ask that question. You see, deoxygenated blood enters the heart via the supreme vena cava and inferior vena cava and fills the right atrium. The atrium then contracts and pumps blood into the right ventricle as the tricuspid valve opens. When the ventricle is filled, the tricuspid valve closes. The right ventricle then contracts, forcing the pulmonary valve to open and the blood to flow to the pulmonary artery. Blood then travels to the lungs and the capillary valve closes. In the lungs, the blood picks up oxygen and releases carbon dioxide. Oxygenated blood flows from the lungs into the left atria via the pulmonary veins. The left atrium contracts to pull blood into the left ventricle through the mitral valve. Once the left ventricle has filled with blood, the mitral valve closes. The left ventricle then contracts, forcing the aortic valve to open, allowing the blood to be pumped into the aorta and from there around the body. The aortic valve closes to prevent blood flowing back into the left ventricle, and the left ventricle relaxes to prepare for the next intake of blood. Without the circulation of blood, Rob's muscles lose oxygen, stop working, and begin to deteriorate.
So Rob's heart stopped, which caused him to lose all body functions and die. Sounds pretty rough if you ask me. Poor kid. He was only in his 20s and already dead. Do you think you know what killed him, Doc?
I can't say I do, Julius. I can't say I do.